All right, this is part 2 of our review of 11.1 through 11.5. So we had a review worksheet. I'm just going through and giving the answers to the different problems here. Sorry about that. So now we go into the section where we're talking about logarithms here. And so let's first start about just how do we start and look at the logarithm of log base 4 of 16. And I could say to myself, okay, it equals x, and then say, okay, 4 to the x equals 16. And now we have several ways that we can solve this. One way is we could use logic and say 4 to what exponent equals 16, and say, well, 4 to the second equals 16, so x must be 2. Another option we have is to say, well, the exponent always equals the log of what's on the outside divided by the log of the base, and the answer there would be 2 as well. So I don't care which way you look at that. When we do the same problem here, I set it equal to an x. I'm going to put it into exponential form. So whenever you see just one log, you need to be thinking in your head, hey, I need to put it into exponential form. So here, 3 to the x would equal, 13 to the x would equal 13 to the second. Well, if 13 to the x equals 13 to the second, x must be a 2. Okay, let's do this one. 13 here to the x would equal 169. Now this one you might say to yourself, 13 what power? 13 squared is actually 169, so x would be a 2 here. Now in 17 we have, set it equal to x, 8 to the x equals 1/64. Well, how do you get 1/64? I know x squared is 64, but to get the 1/64, what you're going to do there is you're going to go, well, it must be to the negative 2, because 8 to the negative 2 is 1 over 8 to the 2, so 1 over 8 squared. So in this case, x is a negative 2. Okay? Next set of problems. Now, we have this unique case where we have the log base 9 of 5x minus 1 equals the log base 9 of 3x plus 5. What you do is you get rid of the log base 9 on both sides. So our problem really becomes, what's 5x minus 1? And when it equals 3x plus 7, what is x? So I'd subtract 3 x's from both sides. 2x minus 1 equals 3. I'd add 1 to both sides. 2x equals 4. And x in this case would equal 2. In 19, I first have to change additions when the log is added to another log into multiplication. So I'm having the log of this 14 is added to the log of this x. So I can rewrite that as log base 3 of 14 times x equals this log base 3 of the 42. Now what I can do is I can say now I can get rid of log base 3 for both of them. So now 14x's must equal 42. If I divide both sides by 14, x would equal 3. In 20, good problem here. We have this problem where I have log of 56 minus log of 8 equals log of x. Now I have this and I have this and I'm subtracting. So what I want to do is I want to change it into a division problem. So now it's 56 divided by 8 equals the log base 3 of x. Now I can get rid of my log base 3's. Now I can say 56 divided by 8 is 7. That's what equals x. Now in 21 we have this unique situation where we have a coefficient of 3. If you remember, that coefficient becomes exponent. So now we would have that log base 10 of x to the third equals log base 10 of 27. Again, now we can ignore our log base 10s, and we find that some value to the third power equals 27. Here I think I just want you to use logic and say, well, then it has to be a 3. Only 3 to the third power equals 27. In this case, again, we have the circumstances where we're adding two logs. So we want to change it into multiplication. So I'm going to make it log base 10 of x times 20 equals the 2. But now we don't have logs on both sides of an equal sign. We have a single log. And when that happens, I want you to change it into exponential form. So change it into exponential form. I want you to see this as its own little grouping. And then we're going to kind of switch places here. And so what I have is I have 10 to the second power equals x times 20, or I'm going to write it as 20x. Well, that 20x equals 10 to the second. 10 to the second is 100. If 100 equals 20x, x must equal a 5. In this case, we have two values and they're being subtracted So I'm going to change it to log base 8 of now n plus 1 over n, and then that equals log base 8 of 4. Now I can get rid of my log base 8s, and I can say, well, really what I have here is that n plus 1 over n equals really 4 over 1. 4 is really 4 over 1. I could do cross multiplication, and I could say that means that 4n must equal n plus 1. So what I did there is I did diagonal multiplication. I said the diagonals have to be set equal to each other. Excuse me. And now I would subtract, oops, sorry. I would subtract n from both sides, so 3n would equal 1. Therefore, n equals n, not m, sorry, 1/3. So my n here is 1/3. Now, when I already have the common bases, 3 to the y equals 3 to the 3y minus 1, I can ignore my bases. So I can ignore the 3. So the truth I know here is that y equals 3y minus 1. If I subtracted 3 from each side, subtracting 3 from each side, I'd get negative 2y equals negative 1. Therefore, y would equal positive 1/2. Same concept here. I'm going to get rid of the 2's. My 5 would equal 2x minus 1. Add 1 to both sides. 2x would equal 6. Divide by 2 on both sides. X equals 3. In 26, now I don't have common bases. So now I kind of have to do a little bit more thinking about this one. What I would take is 9 to the 3y. I would make 9 3 squared. So it's 3 squared taken to this 3y, and I'd make 27 3 cubed. So it's 3 cubed taken to this y plus 2 value. Well, 3 squared to the 3y is 3 to the 6y. 3 cubed to the y plus 2, I have to see this as a grouping, and so it becomes 3 to the 3y plus 6. I'd say most common mistakes, people want to keep that plus 2 there instead of having the plus 6. Now I can ignore the 3's. Now I can say, well, then that means 6y must equal 3y plus 6. If I subtracted 3 from both sides, 3y must equal 6, and then y must equal 2. Same type of problem here. I'm going to rewrite 25 as 5 squared. I'm going to rewrite 125 as 5 cubed. Now I'm going to say, well, I really have 5 to the 4m, and that really equals 5 to the 3m minus 9. So 4m, I did this to both sides, 4m equals 3m minus 9. If I subtracted 3 from both sides, m would equal negative 9. And that's my final answer there. I'm sorry here, guys. Oops. I lost a set of problems. I apologize greatly. I gotta get them back here. I have them hidden. I'm gonna cut that, and then I'm gonna do that. Sorry about this. Get them a little bit spread out here. There we go. There we are. All right, so now my problem here with this problem is I have a single log. Whenever you have a single log, you should be thinking to yourself, how can I change it and put it into exponential form? So exponential form would be here, x squared equals 81. And basically you could take the square root of both sides. X would have to be a positive or a negative 9. Now you can't have, well, we could have a negative base, so I think we're fine here. So we'd have x to the negative or a positive or a negative 9. Here, it would be 3 to the second equals y. So I'm just turning it from logarithmic form into exponential form. 3 squared is really 9, so 9 is what our y equals, and that's our answer here. Okay? Next section. Now, same thing. I want to change it into exponential form. But here, once I change it into exponential form, I notice that I can't find a common base. But what I do is I go back to that change of base formula, that the exponent will always equal the log of the outside value. In this case, it's 15 divided by the log of the base. Okay? So in this case, I would just go to my calculator. I'm trying to find log of 15 divided by log of, I believe it was 12. Now I got to remember. All right? So that's what I got for an answer. All right? So 15, log of 15 divided by log of 12, I'm trying to find my answer here, would be equal to, 1.090. In this case, we already have an exponent, so our exponent will always be equal to the log of the outside divided by the log of the base. In this case, 4.758. Here, sometimes it's x plus 2, and that equals the log of the outside and divided by the log of the base. And what we're going to need to do here eventually is we're going to need to get rid of this 2, so we're going to need to subtract 2 from both sides. So my answer here is whatever log of 15.3 divided by log of 5 minus 2 is. And that turns out to be, let me find the answer here, negative 0.305. Same side of the problem here. I have my exponent, x minus 2 would equal the log of 48 divided by the log of 6. And so here for the 2, I'd add 2 to both sides. So my answer would just be log of 48 divided by log of 6 plus 2. I got an answer to be 2.040. All right, the last couple are probably our most challenging. There will be some like this on the test, where what do we do when we have a variable on both sides? And this does get a little involved, let's just call it. It can be very involved. So what I do for these is I take the log of both sides. So the log of 5 to the 2x equals the log of 9 to the x minus 1. So what you do is you think of, okay, now I have an exponent. Exponents can become the coefficients, so the exponents can jump out in front. So what we have is we have 2x log of 5 equals x minus 1 log of 9. And this is going to get really complicated really quickly. Because even though log of 5 is a number and log of 9 is a number, it isn't an exact number. It's a number that goes on forever. And so if we just use log of 9 and we take it and we rounded it to the nearest value, we wouldn't be getting the right answer. You can't round until the very end. So what I'm going to do here is I'm going to still try to deal with this log of 9 and see if I can get the x's all by itself. So I'm going to subtract log of 9 from both sides. Or not subtract, I apologize, I said the wrong word. I'm going to divide both sides by log of 9 on both sides. So this way here, this cancels out. So now I have 2x times this log of 5 over log of 9. Okay? And that equals x minus 1. All right? Well, really, if I have 2 x's here times a number, and I've taken away an x from both sides, so kind of technically what I want to do is take away 1 x's from here, from both sides. All right? So now I have the 1 here, and I have 2 times these logs, 2 log of 5, this is a number, log of 9, minus 1, and this is all an x, and that's what equals 1. So my x alone would equal negative 1 here. Negative 1 divided by 2 log of 5 divided by log of 9 minus 1. Not easy to put into a calculator, but you can put it into a calculator. So a lot of times you do get these messy values into a calculator. Okay? So let me do that. I'm going to put it into my... All right, so what we have is we started with a negative 1 there. All right, and we said divided by, and we have to have parentheses over everything we divided by. And we multiplied it by 2, and then we said times the log of 5, divided by the log of 9. And then that's everything we had parentheses around that. And then we subtracted 1 from everything, and we had the parenthesis there. That was for the 1x. And we have our answer there. So our answer was negative 2.151, if I rounded it to the nearest whatever. So we got an answer here of negative 2, I got to look again, I apologize, 2.151. Whew. Takes a while. And it's kind of icky. It's kind of icky to deal with. Now the other one, the 35, is even a little bit more. I will not put one, well, I could put one like 35, just so you know. The answer in the end is 0.301, but we've ran out of time, and I apologize for that.